Okay, hello everyone. Welcome to week 5, September 29th. I believe we're at the end of September already. All right, so the first thing I want to do, since there was a few questions or a few concerns, or at least on my part, about the last module, so I'd like to do a quick review of the assignments and quizzes, or quiz, excuse me, only one quiz. Um, so before I bring over the SQL developer, let's take a look at the quiz. I think I have it. Module 4, assignment 1, and actually I most of the responses, I just took some of you that were doing a good job, your random responses. I do want to remind you that there's several ways, especially to use these functions. There's not a right and wrong way per se. So if you feel like for some reason, let me make sure I can see everyone in case there's, you feel like, well, I tried to comment accordingly. So, all right. So what I'll do is I'll display the assignment and just basic queries to look like that. And then I will share my SQL developer kind of underneath here. So the first one was just primarily using concat, as you see. And hopefully you can see my little, can everyone see my SQL developer and the assignment? All right. So, thank you. So see, this is pretty, you can use, there's so many ways to do this. The one thing I do want to point out, basically we want the title or of the column to be that. And that's always an alias. So I know many of you did it a different way, but this was the correct response, the best class, and then Oracle. Whatever you liked, concat, manual concat or whatever to reach that particular display. And you will discover that generally you're working on whatever you're comfortable with, especially with these functions. So you can use any combination, et cetera, et cetera. So that one was pretty easy, just a concat. And this particular person did a concat of a concat. And remember, the concat only has 2 parameters or 2 arguments, I should say. So you see, they just put Oracle and internet, including the spaces, so we get the correct output. All right. And then the second one was just to produce an output that looks like this, using probably the best way to accomplish that is using the substring. And you notice here, we're just using a substring because we're going to pull out net from the string. And we know it starts at position 13, and you could make it complicated, but you can just count. That's fine with me. Oops. To achieve their correct result. So we know that it's 13 and it's 3 spots. So when you run this, I'll get this right eventually. Yeah, it's a little delicate. All right. And so you get that result from that very, very simple substring usage. And then the third one, write a SQL command to display the length of the string. And I don't think anyone had a problem with this. It's just using the length function, and you put in the string, and basically you will receive the result. Let me do this without. My mouse is pretty sensitive. Oh, we'll have fun with this. So let me expand this a little bit and bring it up. See if I can make it easier on myself. So length. And we know that it's 23 characters long, including the spaces. And then the next one, using character function at any function, but this one, we're using the in string to find out where the I in internet. So if we run this, we will find out that it's in spot number 8. And then the last one, I had several iterations of this. I did want you to use the LPAD, RPAD, but I thought this particular student's solution was pretty interesting. They just use a replace function, and they just replaced the spaces with these 4 stars. So that's one of the most unique solutions that I've seen thus far, without worrying about left pad or right pad. So I wanted to highlight that because I thought that was quite interesting. And if you know the replace is just going to replace basically the space before with 4 and after. Yeah. So thank you for coming up with that very interesting solution. All right. So that was the first one. As I said, there were some creative responses to that, and I welcome those. So no right or wrong answer, just you're making sure that you can get the correct result. Let me close that. And the second one was a little bit more challenging, but not too bad, using basically the number functions and number and date functions. I have to make sure I include that because you do use date functions in here as well. All right. If we want to open up the, oops. Oh, I need to open up another iteration of the developer. So let me just wait till this launches and then I'll close it. All right, close. Bring back this. So yes, I just essentially worked on these. Display in Oracle. Employee last name and salary for employees' IDs between 100 and 102. Include a third column that divides each salary by 1.55 and rounds the result to 2 decimal places. So you can do calculations, literal calculations within your functions. So you see here the solution was select last name salary, etc. Salary divided by 155 with the round 2 decimals, remember the positive. And then the where clause was necessary to get the right, to filter out the right employees. And so there were 3, King, Kokar, and those do 2, those employee IDs, there's 3, 100, 101, and 102. So there you go. Pretty straightforward. And then the second one, display employee last name and salary of those employees who work in Department 80, give each of them a raise of 5.333% and truncate the result to 2 decimal. Remember, this is truncate. So once again, using the truncate function, and you see their original salary and their raise of that percentage, which this particular individual used the salary times 1.0533. You can do other ways, but this made sense. And remember, you can perform literal calculations within as an argument within the function, as long as that produces one number, and then you round it to 2 decimal spots, and that's where we get this. Okay. All right, now this one was another unique solution. We haven't gone over case, then else, but someone had some programming experience. Basically, I would accept just a 1 there, but they used mod to test or even and odd. And if it's 0, then it's even, else it's odd, just using some logic in there. So I just want to show you that. And we know that that number is odd. And there you go. So checking for odd, you know, it's mod 2. Very, very common function. And then the next, and 4, use the dual table to process the following numbers, and all of the functions round that number to 2, this number, this to 2, this number to -2, which means you're going to round it on the whole number side, and then truncate the 454 from, so you know you're going to truncate it to one spot. And here we go. The result should look like that. All of this, the criteria satisfied for number 4. So remember this one, because we're going a -2, it's rounding it, up to the next whole number, which is 30,700. So hopefully you see that. And this question 5 there really was not a right or wrong answer. It's one of those challenge questions to ask you. I mean, how would you like your paycheck, rounded or truncated? What if your paycheck was calculated to be 565, which actually happens in financial realms, $565.784. So do you want that to be truncated? So in this case, that 0.004 cents may make a difference, but I was just looking for your perspective of that, and does it really make a difference? And many of you answered that without any problems. Number 6, for DJs on demand, display the number of months between event date and visual wedding and today's date. And remember, this system is pretty old. So this date, you're using the months between, and this particular individual use round, and it's the D events table. So when you run that, it's like 200, and it's a long time since the date probably on this was many, and that's months, right? So it's been a while since that wedding. All right, moving ahead. Using one statement, round today's date to the nearest month, nearest year, and truncate it to the nearest month and nearest year. Usually is aliases for each column. And that was this particular scenario. And so this date, this is September 29th. So nearest month, nearest year. Truncate the month since we're at the end. So it's just going to truncate it back to September, and then truncate the year. So it's going to go back to January 25, which is long past. All right. All right. Finally, or no, we have a couple more. Use the next appointment. Your next appointment with the dentist is 6 months from today. On what day will you go to the dentist? Name the output appointment. And once again, it's just an alias, and using that dual table. Yeah, 6 months from today is March 29th, 1926, or 2026. All right. And then the teacher said, you have until the last day of the month to turn in your research paper. What day will this be? Name the output deadline. And these are just aliases for the output using that dual table. So last day, sys date, basically, that will give you the last day of the month if there's no arguments. So, which is tomorrow. Research paper is due tomorrow. All right, what else do we have? Last one, write a statement that will return the Oracle database employee ID. So it's just employee ID, and their starting hire date between January 97 and today. Display the result ordered from most recent hired to the oldest. I'm just going to be descending. And the hint was you want to use the job history table for this, not the employees table, because job history will have the hire date. So So make sure you order descending, and if you run that, you have 4 individuals that fit that criteria. And yes, it's a while ago, but it does match the criteria. And that was the homework for Mod 4. There were several issues, but hopefully that makes sense to everyone. Are there any questions about that homework before I proceed? Questions or comments? And no. And let me just check the attendance again. Wow, we're missing a few people. But all right, let's move ahead. Okay, so on to, you guessed it, Module 5. And we're going to do another round of single row functions. This is single row functions part 2. I know you're all excited about that, but there's other things that you can do that you can change using single row functions. So our objectives provide an example of an explicit data type conversion and an implicit data type conversion. So essentially explicit, you indicate the conversion. Implicit, that the system creates some type of assumption on what data type you're trying to convert to. And that, yes, both are useful in Oracle or any database management system. And let's see, explain why it's important from a business perspective for a language to have built-in data conversion capabilities. And there are interpretive languages, hence like Python, where it will actually read or pre-read essentially what it assumes that you're trying to accomplish. And if there's a data type mismatch, it will convert accordingly. And that's usually what will help you to accomplish a task that you're wanting to accomplish. So we're going to actually use some explicit conversions like toChar and toNumber and toDate. You can probably guess what those conversions, what the process are performed by those conversions as far as single row functions. And then apply the appropriate date and or character format model to produce a desired output. So we all have an expected output as far as date or even strings. I mean, if we're writing a sentence, etc. We want punctuations, or if we're adding a grocery list or something like that. So, all right. So our purpose, imagine having to read all the required textbooks in text files with no paragraphs, no capitalization. Yeah, it would be a mess. It would be very hard to read unless you like reading that way, not just reading without without pausing, taking a breath. No, it would be very difficult. So fortunately, there are programs available to capitalize, color text, underline, bold center, add graphics. There's even AI to help too, believe it or not. And especially now, I mean, if you're worried about grammar, you're worried about sentence structure, just plunk it into ChatGPT and then it'll basically, or even Grammarly. Grammarly is all AI now, if you did not know that. For databases, format and display changes are performed using conversion functions. Now, just to let you know, in the future, most of the database management systems will be very deep on the back end. To give you an example, and it will go through some type of filtering as far as the result. And this, let me say this correctly. You still need to understand how to format output, but it will be less of a challenge because there'll be other factors within the actual query and how the output is presented to the interesting party. So, but before you get there, and most of the challenge is taking that raw data and making sure that it's presentable. So these conversion functions will definitely help with that. Things like displaying numbers and local currency, dates. That's primarily the purpose of it. I want to start with data types. Data types are important that you understand the basic ones that we'll use primarily for our learning. And for the most part, as far as raw data, this is what you'll see in the field. So When a table is created for a database, the SQL scripter must define the DBA normally must define the data stored in each field. There are several data types in SQL or SQL. These data types define the type, basically what's in that column. And the ones that we'll learn, and this is not all inclusive, but the ones that we will focus on are varchar or string or variable character, which means it can be a variable size, or char. And the difference is that char is a constant. It's not variable. It's always the same size. And it could be from one character to many, but it's a constant char. Just think of it that way. And then number, and then date. Those four are generally the data types that we will work with. And for the most part, at the core level of database management systems, especially relational databases, those four are pretty prominent still, and they've been around a while. And in case you're wondering why it's varchar 2, basically it's essentially like the second version, and it was more appropriate. And it is more appropriate for all types of strings, depending on the size. All right, so those four data types, please remember those. It's very important that you're comfortable. All right, so let's go through a description. I stated a little bit of this, but I'll detail this. Varchar is used for character data, string data of variable length, as I said, including numbers, dash. So varchar is alphanumeric, remember that, and including special characters. You can include that all in the varchar 2. Char is used for text and character, and it's fixed length. I guess I should say that correctly. I said constant, but more appropriate is fixed. It doesn't change. And this does include all those particular types of text that you can add to numbers, dashes, letters, etc. But the difference between the two, fixed length and variable length. Numbers is number, numeric data, no dashes, text, or any other non-numeric data are allowed. Currency is stored as number data type. And you're thinking, well, if you have a currency field, isn't there a current? Well, in a relational database, there isn't. There's other ways that you can convert it, and we'll talk about that later. But for now, all currency are just a number type. And then date. I mean, that's pretty intuitive. One thing that I do want to point out, and you'll see this are a couple things. The current format, I think I stated this before, the default format is that date, a month, the three character month, and then your 2-digit year. But Oracle reads the date. It's actually stored as this very complex number. But it essentially knows, and there's a reason for that. It knows, calculates it from an origin date and all that. But the display, if you're using the data type, is always this date, unless you date a 3-character month and year. Are there any questions about that? Any concerns or confusion? Okay. Not seeing anything in the chat. We will continue. All right. So conversions. So generally, and it's usually when there is an issue with the data that's been added to a table, etc. But the systems have evolved to where there are several layers of implicit conversion. So, but we're going to talk about some, the differences between implicit and explicit, at least more clearly. So Oracle Server can automatically convert varchar to char when it's appropriate, so variable links to fixed. And it's all about efficiency and resources and things of that nature. The system will look for the most, or I guess, in essence, will make sure that whatever the data type is with the scenario is more appropriate for that output, which as appropriate as it can be from an internal system perspective. So it can automatically convert number and date types Now let me back up. Convert varchar to char, varchar to number, and date data type. So it can convert a variable string to any of these data types, depending on what the string looks like. It can convert number and date data types back to varchar. I should just place varchar, either varchar or char, based on, if you're attempting to run that type of conversion. And this is known as implicit, which means that the system is going to assume, and that's essentially what it does. It assumes based on your scenario that you want to display a number or a variable based on, and yes, it will do that. If you perform, for example, if you're performing some type of calculation and that data type is a character data type, it will actually run the calculation, convert it, internally, perform the calculation, and even output it as a character. So there's a lot of system, processes happening to ensure that there's not any mismatch as far as data types. That's implicit was a big thing in the old days. There was nothing like that, and it was always mismatch, and it would just go on and on. And I know that the Oracle developers have really worked on that, especially in the relational database. We have all types of data being processed. All right. So in essence, although this is a convenient feature, it's always best. It truly is best, depending on where you sit as far as the data, to perform explicit conversions, just using your queries. So just to let you know, these are the implicit data type conversions that are within the system: varchar, char to number, varchar, char to date, number to varchar, date to varchar. It's just based on the scenario, you'll have those implicit data conversions. So, but once again, we want to ensure the conversions are correct, so we're not facing any type of mismatch. So we have explicit, which means that you define the conversions. So to convert date to character, to convert number to character, these are the explicit ones now. To convert character to number, to convert character to date, those are, and that's a little pictorial that I picked up from Oracle. I don't know if that makes it easier to understand. It's probably just to remember these four: date to character, number to character, character number, character to date, just back and forth. And you're probably asking, okay, Amos, that's fine. How do you do that? So it is often desirable to convert the date, the default display, right, to something that, we normally don't read our dates. It's usually something different than day, month, year. So if we want that display date to be different than the default date, then we can run something like this, or this is the general format, to char. We're just converting it to char, and then we're going to manipulate the date by using some control characters. They're called, and basically you can format the date whichever way you like. There's so many different options, and the specified format must be enclosed in single quotes, as the syntax indicates here, and it is case sensitive, and you'll see here in a minute what is meant by that. And you have to have a comma to separate the specified format from the date. And any valid date format element can be included. And you're asking, well, we haven't been exposed to date format elements. Well, I'm going to start with a few and then show you a chart that has, and a lot of examples. So this will be a good chance to pay attention. So the SP, when you use this as a format specifier, it means spell out a number. The TH, that's that nth or ST, it's the ordinal. It's how it's ordered. And it'll make sense when I give you the example. The FM removes any padded blanks or leading zeros. And like if it's a single digit day and it's stored as 01, you can use the FM to remove any of that. All right, so those three are the kind of the top level, but here, as far as this specified format, these are some of the general ones that you would normally see. And let me go through these quickly. If you want a 4-digit year, it's the YYYY. If you want the year spelled out, like 1983, actually, if you use year, it would be spelled out with the words. MM is a 2-digit value for the month, and then month is the full name of the month. Then MON is that 3-letter abbreviation of the month. DY is your 3-letter abbreviation of the day of the week. Monday, Tuesday, Wednesday, month to day, full name of the day of the week, DDD or DD or D, numeric day of the year, month, or week. Numeric day of the year, month, or week. So DDD or DD or D. The SPTH will give you the spelled out all caps of whatever you're indicating. So 14th, and usually it's a day. Usually don't use it with a month. And then to further expand that example, if you use the D with the initial, the first letter capitalized, then you get this type of display. And then all lowercase. So you see the correlation between the format specifier and how it's displayed. And remember, this is spelled out. And this is different than this, and I know that can be confusing. This is the numeric day of the year, so you can have it a single, double, triple digits, right? All right. And then time, 24-hour, 12-hour, minute, second, and then the AM, PM added on if you want. And then here's if you want DD of month, meaning because it's going to be month, full name of the month, or you can have that 3-letter abbreviation, but it'll give you the day. And that's a format now. If it's the 23rd of December or 23 of December. So does that make sense to everyone? Those formats are very important that you can, see the essence of how those can be used to format your outputs. So the one thing you want to note that specifying the elements as far as time, hour, minutes, seconds, and AM and PM, just as I indicated. So I'm going to go through several examples just so you can see how, and this is all in the format. Remember that in these date conversions, we're taking that default date format and forming it into another display. And use the toChar function. We're looking at the higher date, and we want month, full month spelled out, 2-digit day, a comma, and then the 4-digit year, which is normally how we would read the month, right? So you see the format looks like that. And there would be a lot of people that would say that looks a lot more of what I'm used to. And we can use the alias, and we can also see how this will be displayed in our column header. Okay, and here's another one. If we wanted to remove all the padding, see all this padding here, we can use the FM. So remove the padding as far as spaces or zeros. And then that also removes the spaces in front of the month and the zeros in front of the day. The year is going to be the 4-digit year. So now it's nice and clean. And it just has the FM in front of that same display. So I don't know. This probably looks better, but that's all nice and lined up because it's going to format it that way for the output. Okay. More examples. Here's one with the nth, the DDTH. So that's either going to add the TH or the ST when it's 1, or the ND. I don't have if it's 2, or an RD if it's 3. We do have an RD down there. So first, second, third, and then all the nth into. So same thing, nice. Remove our spaces, and then we're just adding that. I forget what that's called. Does anyone remember what that's called? The nth iteration, or it has a specific name, but yeah, you see the format follows the type of the number. And then Here we go, a little different format. We're going to take the day of the week spelled out. So now we have Wednesday and then 17th of June, 1987. So remember, these are all two char, so we can actually add this nice and defined format for our output. All right. We have even more examples. Here we're taking that same, but we're spelling out, we're using the SP to spell out the day with the nth in it. So 17th, 21st, 13th. Yes, and the system will do that. That's a little wordy, but maybe someone wants that format for the output. So you just add the SP, which spells out in a word the number with the TH or ST or ND or RD. And still another example. So here we're adding the term of, and notice within the single quotes, since we're adding a string or a word or of, it will remove the spaces, day, add the nth spelled out of, so Wednesday, 17th of June, 19. And you notice we use year here instead of YYY, and year is the year spelled out. So that's very wordy. I don't think I've ever seen anyone want the date to look like that, unless it's on a legal document or something. But that's how you would form that format. Just taking that default date and satisfying some requirements. Yes, more examples. And this is just using sys date and time. So if we wanted the hour and the minute of the time, we can extract that. And this is just using the dual table. So 902, pretty straightforward. And if we wanted AM and PM, we just, and that's all lowercase, and it will be lowercase. Sys date, pulling out the time. And if we wanted to the second, I ran this at 9:02, almost 9:03 in the morning. Okay, just another way of formatting all the attributes of date and time. All right, let's move on. That's primarily date conversion and time to a particular format. So remember that numbers stored in the database have no formatting. This means that they have no currency signs, no symbols, no commas, nothing. So we want to add formatting by converting it to char. And that's kind of, so to char number and then whatever your format model is, just the same as the date. And here are some of the elements that you can use. Basically, if you want to essentially the numeric position of the number of 9 to determine the width. 0 display leading zeros, $, floating $, you can use that to do currency, floating local currency symbol, decimal point in position, certain position. So using the 9s, and this is the format that we would get from these. Using this particular, in this case, essentially the 9s is telling you what type of format. So if the number is 1, 2, 3, 4, then these are all the different ways it's going to be formatted based on the element and where the particular elements are added to the number. Here we're adding a minus. Here we're adding parentheses. Scientific format. Multiply by 10. So all of these particular formats you can display using this number conversion, or these elements as far as number conversion. All right, let's look at some examples. So select to char salary. from employees. This is the format. We're actually formatting the salary, the monthly salary. Dollar sign, we add the dollar sign, and then the actual formation or display of the numbers, 99, comma, and we get, it looks like it's the salary, right? Well, we just went through that. Yeah, this is just another iteration of that. Oh, it was a test. So can you identify the format models? And I already showed you this. So yeah, the $3,000 is that, the 4,500 is that, the 9,000 with the decimal point is that 99. Yeah. And then the 000, we got some leading zeros. Yep. So he's just taking those using the two char and adding the formatting. Pretty straightforward, right? All right. It is often desirable to convert a character string to a number. So this is an actual string. And see that it's within the double quotes, and we're going to just convert 5,320 to a number. And this is it. We have to tell the system the type of format the model is, the string model is, to make sure that we can explicitly convert that to a number. And generally, and you'll see that it basically changes that to the actual number. You rarely see this, but it does often occur. I mean, you rarely see that someone's adding a number to a character data type. So, but that's the way you would convert it to number. Two numbers probably, in my experience, the least used, but it is useful to understand that. There's some caveats. So the bonus column includes data which contains 4 characters, and be careful of this. We're trying to convert 4 characters to 3, and you'll get a mismatch. Invalid number. Yeah, the system is that intuitive that that error will occur if you're trying to convert this bonus. This bonus column has 4 digits, and we're saying you can't force a conversion from one size of a number to another because it becomes a different number, obviously. So if we change that to 4 nines, then we would get an output. Okay, this would be the bonus, if that's the example. But just remember that, make sure you understand what's in that column. It's always paying attention to the data, et cetera, anyway. All right, moving along. So to convert character strings to a date format, same idea. If this was a character or a string, and if we wanted to convert to a date, we would have the character string within the single parentheses, and then some type of format model. You see here, we want to convert this November 3, 2001. We have to let the system know that it's month, day, year, and it will return the date in the regular default date format. Now we just converted that string to a true date. Okay. And here's, so when making a character to date conversion, the FX, or format exact, that's what the FX stands for. It's another one of those conversion parameters, or a modifier, specifies exact matching for the character argument. So if we had the following example, if this was a string, entered or in the column this way with no space, and we want to make sure it's May 10th, and we would use the FX. So here's our example, this February 17, 2025. We will just use the FX month, three letter abbreviation of month, day, and then year, and it will change that or convert that to your regular date format just by using that FX in this. So because it will not recognize that implicitly as a date. So that's the key here. So this is when you would use the format exact modifier. And there's some rules for the format exact, punctuation and quoted text, and a character argument must match, so it must match everything but the case, meaning lower, upper, or lower. The character argument cannot have extra blanks, yeah. And without FX, the Oracle server ignores extra blanks, yeah. Numeric data in the character argument must have the same number of digits as the corresponding element in the format model. So without FX numbers in the character argument can omit, yeah, and you may not want to omit leading zeros. So be very careful if you're using FX, the FX modifier, because it will modify it in accordance to whatever you identify as the format of that display, if that makes sense. So let me pause here. Any questions about that? I mean, there's several ways to modify data. Okay, something in the chat. Okay, glad you're here, Nicole. All right, let's move on. Here's some examples of the FX. Just take a look at these and see what the result. You see that the result is the same date, but we have to identify to the system how we're converting that, whatever the format is, to an actual date using FX. So month, date, year with the spaces, etc. You do need to make sure that the identifier matches the date format exactly, and we won't have any issues. Okay. All right. I know that was a lot of information. The conversion can be daunting, but all you have to do is just reference all of the little rules. If you want to deal with numbers to dates or characters to dates, you just need to pay attention to the format and use the specific modifiers accordingly. So we have char date. As far as data types, we have the DD date format, or the default format, I should just say. Some of the conversion functions, you have the FM, you have number, to char, to date, to number, all conversion functions that you can use to set your output. And then the data type varchar, which is your string, which is, remember, fixed length and variable length, and then number, and then date. Those are your data types, mixed in with all of this other things that you just bombarded you with. Okay. Whew. Take a breath. We will move on. On to null functions. I know you're really excited about that. Basically, our objectives: demonstrate and explain the evaluation of a nested function. Lists at least 4 general functions that work with any data type and related to handling null values, which is so important. Explain the use of coalesce and NVL function, other functions to handle null. Null is one of the most bothersome non-entity, or actually it is an entity, but not defined part of your table that can cause issues. Explains the use of general functions to deal with null values. In data, construct and execute SQL queries that correctly apply and will apply these functions. And NVL, NVL2, nullif, and coalesce. So besides the functions that control how data is formatted or converted to another type, SQL uses a set of general functions to handle null. You may be wondering how these values, which are not defined, unassigned, unknown, can be, well, basically, you need to account for them. So null may be nothing or not defined, but it can affect how expressions are evaluated. That's the key. So in this lesson, we're going to learn about how to handle nulls. So remember how functions are evaluated. You have applied, we've applied single row functions in simple statement. So it is possible to nest functions. This is one of the lessons that was thrown in here by Oracle. So it is important to know how nested functions are evaluated. Nesting refers to one thing being contained within another. basically you have an inner function, an outer function, like an A contained within a nest. The following example is a nested function. So if you take a look at this, select to chart, and you have next day, add month. That's a nested function. Add month within next day. And then and some of you are already using these. Basically, you have to make sure your parameters are set. Each of the functions have certain requirements as the number of arguments or number of parameters. So this is the key. I would definitely recommend that you line up like this internal function first and make sure you get a result, and then nest it within. So the internal function is add months. The next day is your nested function. So this is something that can be confusing, but let's take a look. Let's detail this example here. So to char, which is your function, and the next day. So how it's evaluate, the higher date is going to have 6 months added to it. So that's your inner. The first Friday following the day return at step 1 will be identified. That's next day, right? Next Friday, next day, Friday, right? And then step 3, the default date format will be formatted to read and display, a certain way. This day, December 18th, 1987. That's the to char, and then this format here as next evaluation. So this is a little clearer. It should be next evaluation. But just remember, just think of, before I go into null, when you have nested, you start with the internal, and you just 6 months added, format for the next Friday, and then the actual format of the date. Inner to outer. That's my recommendation there. So that's the quick lesson on nested functions, because you're all using those already. Remember the concat, and that's an example of a nested scenario. All right, null values. So way back in the beginning, we talked about, we mentioned nulls, how null is unavailable, unassigned, unknown, or basically inapplicable. So as a result, it can't be truly tested or evaluated. It's because it's not equal to anything. It's not even equal to 0. Remember that. But just because it really isn't anything doesn't mean that it's not important. So imagine this kind of ridiculous question. Is it true that x equal y? Well, from our math days, unless you're in algebra or something, or calculus, you'll say that that's not true. But in order to answer that, we have to know the values of x and y, right? So with that, and I know that's an awkward lead-in, but with that, let's just consider the 4 general functions that are really associated with null values. And these are functions, so you want to treat them like functions. So it's NVL, null value, NVL2, null if, and coalesce. And these can help you to get through some of the difficulties when handling null. All right, let's go through these. NVL, this is a function that converts a null value to a known value of a fixed data type, either date, character, or number. Yeah, those are our data types. The data types of the null value column and the new value must be the same. So the data type of the column that you're evaluating, well, obviously you have to substitute or convert that value to the same value that's in that column. And here's the syntax. NVL expression 1, value that may contain a null. Expression 2, value to be substituted. There's always better. All the words are probably more confusing unless you see an example. So this query uses the NVL function with character data. So we're selecting country name, NVL, the function, and yes, it will show that way. You lose the little blue coloring. Internet extension, and we're going to substitute. If that's null, we're going to substitute the word none. So now it becomes a value. from our internet as internet EXTN, which is extension from WF countries. So where location is equal to Southern Africa, and we're just ordering it descending, which means the nulls are going to be first. So you just see that whenever there's a null in here, it says we don't have an internet extension here. Otherwise, we have these extensions for these particular countries. And that's, I don't know, that's mostly easier to read than seeing that null there because you don't really know what it means. And that's the main function of an NVL, just to substitute it to something that means something that will mean something to someone reading those results. Okay. So remember, the replacement must be the same data type. So this example, commission percentage is a number. So we're just replacing that number instead of null to 0. So, and these are individuals that do not have a commission percentage in those two departments. So as you can see, and basically if you're running or producing a report about commission percentage, then you can say not equal to 0 and so, but it's just another way to handle nulls, even visually. Here's another example, date of independence. Either there is a date or we substitute 1 January 1999. Whoops. Which means they don't have, or they will be, well, I don't know. Yeah, at some point we will update the data that's in our Oracle database to be a little bit more, since we're in 2025 already, but anyway, it's just a way to handle nulls. You just replace it with a known value. So you could use NVL function to convert, basically, to sum this up, you're going to take the null out and put something that someone can read through it and associate an actual value for calculations, for whatever's needed. Remember, null does not calculate correctly because it's not defined. That's a key part of handling null. And so if we wanted to calculate, perform some calculation on commission percentage, we use that NVL on 0, and then we won't have any problems converting that because 0 multiplied by 0, yes. Anyway, because if you had null there, you would just end with null. It's a lot easier. It's more difficult to convert values that are not defined. All right, that's NVL. We're going to go into NVL2. This function evaluates an expression with 3 values. First value, if the first value is not null, then NVL2 function returns the second expression. If the first value is null, then the third expression is returned. The values in expression 1 can have any data type. Expression 2 and expression 3 must have the same data type, or can have any data type except long. And that long is a type of number that we're not going to deal with, so don't worry about that. The data type return value is always the same as the data type in expression 2, unless expression 2 is a character data, in which case the return type is varchar. So generally, you're once again dealing with the same, just keep in mind, keep the data types similar. Here's the syntax. An easy way to remember NVL2 is to think if an expression 1 has a value, substitute expression 2. If expression 1 is null, substitute expression 3. So expression 1 has a value, you want to use, if expression 1 has a value, substitute expression 2. If expression 1 is null, substitute. Yeah. So let's take a look at this example. It's probably easier to understand. NVL2, we're looking at commission percentage. Remember, there's a lot in that employees tables where commission percentage is null. So if commission percentage has a value, we're going to substitute salary plus salary times commission percentage. If it doesn't have a value, then we're just going to substitute for just the salary. I know that seems a little odd. We just want to make sure that if there's a value here, then we're we're adding commission percentage. If there's no value here, then we're just looking at the salary. I know it's really, I think about this and it's really hard to wrap your head around. And there are situations where you would want to use that, so it does calculation for you. So you can do it throughout a whole table. Let's say you have 10,000 records in there. Then you can run this NVL2 to handle the nulls without having to do single calculation for each individual that has a commission percentage in this example. Does that make sense? Or NVL2 is always a little harder to wrap your head around. I do recommend just running some of those examples to grasp what's happening in this NVL2. Remember, it's 3 parameters or 3 arguments. And so either you're substituting it for one thing because it has a value, or you're substituting it for a second thing because it doesn't have a value. Hopefully I made it even more clear or less clear. Muddy. Anyway, that's another way to handle nulls. We're just speaking to handling nulls. Another way is null if, and this is another function. It compares 2 expressions. If they're equal, then the function returns null. If they're not equal, the function returns the first expression. Oh, I know these even give me a headache sometimes, but there are scenarios where you can use these, and it makes sense to use these. So in the example I'm going to show you, the null if compares the length of employees' first and last name. If the length of both names are the same, then null if returns a null, as in Curtis Davies. Otherwise, expression 1 length, the first name is returned. So null if they're the same, remember. So in line 1, Alan and Abel are not the same as we look at the length. So it will return the length of the first name. But Curtis and Davies are the same, so it returns null. And you're probably thinking, why would I ever need this? I don't know, maybe you have something going on that's looking at the length of the name or something in this scenario, or something where you're comparing 2 values to see if they're equal. And as you go through that, if you ran that query, you see that it is, every null is because the names are the same length. I know that's exciting, but that's null if. Another way to recognize or handle nulls. Coalesce is and its iterations have been around a while, probably the longest, but it's kind of an extension of the NVL function, except coalesce can take a number of values, and the word coalesce literally means to come together, and that's what's happened. This is what happens. If the first expression is null, the function continues down the line until a not null expression is found. Of course, if the first expression has a value, the function returns the first expression, and then the function stops. Done. So basically, it's looking to see where the nulls are. And the syntax is coalesce and then all of your expressions. And you can have any number. And yes, it can have some usage. So let's look at the select statement. If an employee has a value not null for commission percentage, which is a good one to use because there's many employees that do not have a commission percentage. So select last name, coalesce commission percentage, salary, and then 10 as con, so for commission. So in order by commission percentage. So basically, if it has commission percentage, it has a value, right? So it's just going to return that. If it has a null, then it's just going to return the salary. And you're probably wondering, what's the 10 for? Basically, it's going to return the number 10 if an employee commission percentage and salary both are null. So we won't have a number 10 in here, but that's the way the coalesce works. 3 values, but and it just goes until it stops when there's a value, and it goes until there's a not a value to return, and it will return a 10. Yes, there are uses for that. I've used coilies quite a bit, so yeah. I'll let you ponder that for a second. I've probably given you a headache. This is the headache lesson anyway. So that's handling nulls. It is important to understand how to handle nulls and what you can do with any of these functions. Remember, these are all functions to handle nulls. So our terminology for this section, NDL, NDL2, null if, and codes. And you will have plenty of opportunity to test these. And they have their usages, so I'll just kind of leave it at that. All right, our last topic in this module or section, the conditional expressions, compare and contrast, decode and case, and someone actually used the case, construct and execute. These are our objectives. A SQL query that correctly uses the decode and case, and decode and case are just two types of the same function, for a particular purpose, and I'll explain what I mean there. And then construct and execute two methods for implementing if, then, else. And this is a conditional logic. So think of it, if it's this, then do this, or else do this. All right. Okay, so why do we need this in SQL? Being able to make decisions is essential in data modeling. Modelers have to decide which business functions need to be modeled and which do not. The data modeling process requires that you analyze information to identify entities, resolve relationships, etc. A typical decision could be if a business needs to track data over time, then time may need to be an entity, or else time should be an attribute. And I know you can wrap your head around that whole scenario, right? And this is truly all about decision making. If it's this, then you do this, else you do that. That's probably the best way to understand these conditional statements. And decision making is a process of programming, even scripting in SQL. So think of the last time you had to make an if then else kind of decision. If I get my homework done before 9, I can watch television, else I can't watch television. SQL, these things of choices involve conditional processing methods. Knowing how to use conditional processing makes decision making easier to get better, to get the data you want easier. That's a mouthful. Knowing how to use conditional processing makes decision making to get, not to change that. All right, the two conditional expressions are case and decode, and I'm going to explain those. Well, probably think they better explain that. So you already studied null if, which is a logical equivalent to the case expression, and that case compares two expressions. Null if compares two expressions, and if the two expressions are equal, then returns null if they're not. Case is very similar to that. Now, there are two sets of commands or syntax that can be used when you're dealing with these conditional expression. There's the ANSI ISO standard cis119D-O-lecture-5, which is still applicable. And yes, it was created in 1999. Back then it was very modern, but now it's getting old. And then there's the Oracle proprietary statements, which Oracle continues to build upon in very useful ways. So the two sets of syntax are very similar, but there are a few differences. In this course, we will learn both sets. I can tell you right now, ANSI cis119D-O-lecture-5 is still pretty much the standard, but Oracle is, taking over some of it because of their proprietary approach, obviously. And now MySQL and PL SQL, all of those are using the proprietary statements. So excuse me. Case and decode are examples of these, and that's case is the ANSI. You see this more in SQL, the ANSI 99, and decode is the Oracle proprietary, which means that decode you probably won't see outside of Oracle, or in fact you won't see. And both statements return the information using different syntax. Okay, the case expression basically does the work of an if then else. Data types in the case when else expression must be the same. And our syntax is case in your expression, when comparison expression, then return expression, and so on. So it's usually a case when, as many as you want. Be very careful because it can become confusing. And then it ends with an else. Else is just if all that is, if the conditions aren't satisfied, then you just do this. And then you have an end. Oops. Oh. And that's the syntax of how you write a case. And I had one of those examples that I showed you way back in mod 4, which that student really jumped ahead. So here's an example. Select last name, case, department ID. That's your satisfier or your condition. When department ID is 90, then that's management. When department ID is 80, then that's cell. Department ID is 60, then that's IT. Else, it's another department or other department. And you're going to list that as department from employees. So it's going to select all the last names and give them an department identifier, right? So the output looks like that, right? We're identifying management, sales, and IT, and then so there's a case example, right? And yes, what I just said, basically, if 90, then management, etc. The decode is pretty much the same. The syntax is different. It still does if this. Remember, this is Oracle proprietary statement. So it's decode in column 1, expression, search 1, result 1, and etc. And then a default, which is kind of the same as case. I'm pretty sure case is easier to, well, it really depends on your history, but if the default value is omitted and null value is returned, and generally you want to include the default value so you don't have to handle null. So that very same example looks like this with the decode, with the Oracle proprietary statement. Select last name, decode department ID, which is your testing, your searching parameter, and then you just separate each department ID. And so the verbiage is a little bit harder, or the syntax is a little bit harder to follow, but this does exactly the same thing. And you can run either of these in developer, both the ANSI or the SQL 99, the ISO, or remember, this is Oracle proprietary. It's kind of a shortcut, but you really need to understand that for the if then else. And you read this, if this person is in department 90, then we're going to say there. We're only listing the last name. And then remember, notice this is just another function, and we're identifying that function as with an alias department. And so please make a note of the syntax for both of these and the differences. All right, and they do both the same thing. All right, so that's your conditional expressions. Very, very useful if you want to substitute or test a search, case, and decode. Remember, case is your ANSI ISO 99, been around forever. Decode is the Oracle proprietary statement. All right. So that is the lecture for today, but let me highlight the responsibility for the week. I know you're all exhausted, but I can't take any more. All right, we're in module 5. I do want to mention we're getting into October. At the end of October is midterm, so begin to make sure you gather your notes and begin to look ahead a little bit. But don't panic. It's everything that I cover, and you get a chance to print out or look at your cheat sheet or review. But anyway, I just wanted to introduce that briefly. So this is lecture, as As usual, I will include the lecture slides and the recording video. And as usual, we do have some videos. CAS is another one. I didn't cover that, so make sure you watch this video, this conversion. CAS is one that's been around forever. Some of these functions are newer. And then simple case and the Oracle format. Yeah, I think I just changed these recently to make sure to give you an idea of some of the conversion functions, especially the ones that I haven't covered. Good resources. Please do not ignore them. And then your practice queries. Yes, there's a ton of them. This is probably the time you really want to start practicing with these to see how the conversions work. You get a better idea of the data types and see where it's appropriate for some type of conversion, and do NVL, NVL2, coalesce, and all of that in your practice, and some case expressions as well. I think I'm pretty sure there's some nested functions, but nested functions are, once you have an intuition about how it's evaluated, it's a lot easier to deal with. So you have your practices, you have three sections of practices and solutions as usual. And this is just a way to practice some of the things that you'll see in the assignment, some of the things that will help you on the quiz. And we do have the solutions that's connected right to the practices. So very useful. And then for this week, we only have one assignment. I think it has 7 questions. And remember, the best thing to do, or what I'd like, is go ahead and download this and add your screenshots. Remember, it is required for you to run your queries in the developer and add your screenshots to the document, this document, or a document of your choice, and then submit it as your posted as your submission. So one assignment and then one quiz. One thing I do want to point out, and there's 3 sections. The quizzes, after the due date, the quizzes will not reopen. So, but if you miss the assignment, I will allow you to submit it via Canvas message. You just get a late deduction, but okay. Any questions or concerns? That is module 5. Are we okay? Are we still awake? So let me stop sharing. So, and that was a lot this evening. If you have any ongoing questions, you can always send me a message. Please don't forget about that. Otherwise, I'm glad you all are still with me. So please take care and finish your assignment, and I will see you all next Monday.
Thank you. Bye.
Bye.